to the second episode of the topic on welding. This session will be a little bit longer session, approximately 25 to 30 minutes. But I insist all the viewers to watch this session till its end because here we are going to see very important aspects of welding which are not commonly discussed but which are very important as far as the welding is concerned in majority of the industrial construction projects. So, moving forward, we will see the different types of welding which we will go through. So, here to give you a small introduction, the one is the stick welding, which is shown here. This is the filler wire, that is the filler metal, which is an electrode, and this is the base metal. This is nothing but the normal arc welding MMA. Just go through we will do before we start the actual presentation on this. The second one is the MIG welding. Here the stick welding or the arc welding and the MIG welding, we are going to see the videos, actual videos in the coming slide. In MIG welding and arc welding, the basic difference is MIG welding is used for mass production welding, where we have a continuous wire, which is the electrode, and in case of MIG welding, that wire is not coated with certain non-metallic flux, whereas in case of arc welding, we have a flux coated electrodes, and there is a gas shielding continuously which takes place in the MIG. Like here you can see the blue color is nothing but a shield of carbon dioxide gas. Because carbon dioxide is heavier, it covers the molten metal here and it avoids the oxidation of the molten metal. So this is the purpose of using the carbon dioxide, because it is heavier and it doesn't oxidizes the molten metal. That is the most important function of the carbon dioxide, which is MIG, means metal inert gas welding. Inert gas is non-reactive or non-oxidizing, and that is the carbon dioxide. So we are going to see this video, and then we have a gas welding. Gas welding is never used for the pipe or equipments, because we cannot go for the X-ray quality welding when we are using a gas welding. It is popular mostly in the automobile section, where there is no such requirement of X-ray welding. Then we have a TIG welding. We have discussed this TIG welding. This is the filler metal. And again, here there is a gas shielding. Here we have an argon in case of TIG. TIG is tungsten inert gas welding, because this is a non-consumable electrode, and it is made of tungsten. And this is a filler wire. The filler wire is of the same metal as that of the base metal in majority of the cases. Of course, we also have dissimilar welding techniques where the filler wire may be of some different metal. Mostly we are now discussing about the joint between the similar metal. So filler wire and the base metal both are of the same material. So here TIG welding is used especially in the case where we have lower thicknesses, thinner, thick, thinner plates where we have to weld it, or some shells which are or pipes which are very thinner for small bore. In that case, we go with the TIG welding. So now we will move forward and then we will see how these different types of weldings are organized. So this is a brief overview we will take. This is a welding and this is the fusion welding. So in fusion welding we have something as arc welding and gas welding. But in arc welding we are going to discuss arc welding because the for the reason that gas welding is never used for industrial construction, that is the process plants construction. We never use gas welding. So we will focus on the arc welding. So in arc welding, primary one is the MMA, that is the manual metal arc welding, and we are going to watch a small video on MMA, manual metal arc welding. It is the most fundamental type of welding where you have the electrode, then you have the holder and the earthing, and then you go for the welding. The current is set as per the thickness of the electrode. For higher gauge electrode, thicknesses of the electrode, we require higher current. So, and for the lower, we require lower current. So 12 gauge electrode is the lowest thickness, whereas the 6 gauge electrode or the 4 gauge electrode is the highest thickness of electrode that is used for the MMA, manual metal arc welding. Then we have the TIG. As we have discussed, TIG is used for some special purpose where the thickness of the pipe or the plate is comparatively lower. And if we go with the MMA, manual metal arc welding, then there are the chances that the base metal may get burn off. Okay, and there cannot be a good quality of weld. We cannot achieve that. So for that, we go with the TIG, tungsten inert gas welding. Then we have something called as CO2 welding, that is the MIG welding, for which we are going to see the video. This is a mass production welding for as compared, it is exactly the same, the method is different, but it is also arc welding, electric arc welding, and for it is the also called as a MIG welding. Then we have something called submerged arc welding. This is the machine weld which is done for majority of the cases high diameter pipes, 50-inch, 60-inch, 80 inches pipe, which are placed on a rolling positioner or a tank rotator. It keeps the pipe continuously rolling at a lower speed, and in that we go with the submerged arc welding. So without wasting the time, we will see how this arc welding takes place. There is a small video, just have a watch on this. So this is the joint area. These two members are to be joined. This is called as tag welding. So here we can see the welder is creating a tag or a small joint, point by point, 1 point, 2 point, 3 point. Okay, and because we don't this welding is done without using the screen. The camera has not been it is not with the screen, we cannot see it directly. So we can see there is a chipping hammer, and when this hammering takes place, there are some layer, there is a layer which is get chipped out, and that layer is of the flux. So flux is something, a coat of a non-metallic material which is on, see, this is the quality of weld. We can see point by point by point, drop by drop, we can see these are the drops actually which were placed by that arc welding. So this is how the welding is done. Now I think here he will go with the full welding. So continuous welding process we can see here. So this is a single hand welding. In one single go he has done the welding. So this is the code we can see here. This is called as burn off. We can see these are the defects which we are going to discuss. Burn off means something has burned off here. Okay. So now it's okay. So here, okay. So this is the complete arc welding process. We can see the angle. So this is 90-degree. This member and the other member both are at 90-degree. So the angle between these two members should be 45-degree. The electrode, in order to get a good quality weld. So these are all the prerequisites which are required, and a good welder has to follow this. Okay, this is the called as chipping. So chipping out the flux layer. Before you go for the second layer, it is a very important that you chip out the all the flux layer. Otherwise, the flux layer may stuck the flux particle, which are a non-metallic particle. They may stuck between the first layer and the second layer when the welding material is molten. So that is a bad quality welding. So you should avoid that. So remove all the flux and clean the joint properly with a wire brush. So from all sides the welding is being done. This is called as the tag welding. One, two, three, four, step by step he is doing the welding. And the other one is the single hand welding. In one go, one single go is completing the entire welding. So the gap between the base metal and the electrode, that is called as the arc length. So if the arc length is higher, then we get a bad quality welding, and there will be no proper fusion. If the arc length is lesser than required, then also there will be no proper arc and the metal will not fuse properly. So there will be some other defects. So this was all about the MMA, manual metal arc welding. Now we are going to see the MIG welding. So this is the MIG welding we are going to see. This is the torch, and it is supplied with a cable or a pipe. So that pipe is a telescopic. It is having inside there is a reel or a wire. See, this is the wire. This is a filler wire actually. This is a machine which is continuously feeding the filler wire. This is a reel which is carrying that filler wire. This is a copper nozzle. This is a torch or the gun. It is called as gun. This is the switch. If you press this switch, there the arc will strike. Okay, so this is the quality of weld which we are achieving. The blue color layer is nothing but surrounding the filler wire. There is a continuous flow of inert gas, and which is nothing but the carbon dioxide. We are using carbon dioxide. So here we can see the carbon dioxide. See, carbon dioxide is heavier gas, so there will always be a layer around the molten metal of the carbon dioxide, and till the molten metal is solidified, the layer will be there, and it will protect the oxidation of the molten metal, and uh, because of that we are going to get a good quality welding. So this is the gas diffuser. We have seen gas diffuser means the device from which you will get the gas will come out. It will diffuse in all the directions and come out from the nozzle. Gas means the inert gas, that is the carbon dioxide. Okay. This was all about the MIG welding. So now we will move ahead and see what are the different types of weld joints. So here we have one which is called as the butt welded joint. Here we can see there is a V shape. So this V shape is very important because it allows the molten metal, that is the filler metal or the electrode metal which is molten, to flow inside this joint, and thereby we get a good joint. And this is a lap joint. Lap joint is normally recommended when we have the thickness is lesser. In that case we go with the lap joint, because if we go directly face to face, if suppose this face and this face will come uh, facing each other, then there are chances that we cannot get good quality weld. It may get burn off. So in that case go with the lap joint. So this is a corner joint. We can see here this how it is arranged. This is the H joint. This is the T joint. Okay. And now moving forward, we will see a very important and very crucial topic in the subject of welding is the defects. See, when we talk about the welding for piping and for equipments, of course, the structural welding, we don't have something called as X-ray welding. Of course, for nuclear applications, we require X-ray welding. Basically, what is X-ray? X-ray means when you go with some, what is welding? Welding is nothing but connecting or joining two dissimilar plates. That is called as a one homogeneous with a homogeneous joint. Okay, since even though they are dissimilar plates made of similar metal, they are joined together in such a way that they are one single piece, one single entity. So that is welding. So what is X-ray? X-ray is nothing but we identify that the joint between these two dissimilar metals that doesn't have any crack. That is purpose of the X-ray. And of course, if suppose now at this time, at this moment, there is no crack, but there are certain defects within the welding. Majority of the cases, 12 types of major defects are there, which we are going to discuss. Some of the most prominent defects we are going to discuss. We cannot eliminate these defects 100%, impossible to eliminate. Only we have to take certain precautionary measures by which we can minimize these effects, and if we minimize these effects, then we can get good quality weld. Means this welding may develop crack in future, but relatively it will take more time. Like for example, the life of a plant is 20 years or 7,000 cycles. So whichever is earlier, that is the life of the plant. So when we say this is X-ray qualified welding, that means there will be no crack in this weld during the life of the plant, that is 20 years or 7,000 cycle. So this is the bottom line for the X-ray qualification. So now what is important as far as the X-ray qualification, the joint defects are checked, and it should be within certain permissible percentage or limits. So now we are going to see one by one what are these defects in the welding. So first an important defect is the crack. Crack is very common, and from the name itself you can get it that there can be some hair minute cracks. And why this crack will be there? The first reason is improper welding current and high speed. So improper welding current means if the current is too high, so what will happen? The metal will immediately uh, melt, and it will not get sufficient time to penetrate in the base metal. So what will happen? So this metal which is deposited by the filler electrode, it will immediately get solidified, and because of that there will be crack. Second case, if we are so for the remedy is that use proper welding current. So for a given thickness of plate, a thickness of corresponding electrode is also specified, and for that a current is also specified, welding current in amperes. So for higher gauge electrode, 6 gauge or maybe 4 gauge, 8 gauge electrode, we have higher value of currents, whereas for lower thinner electrodes like 13 gauge, 12 gauge, lesser current amperage is required. Of course, if suppose we are using welding current is right, but even then we can get a crack. Why? Because when we are welding for a higher thick plates like for pressure vessels and all, there we have, especially in the nuclear projects, the shell thickness or the pipe thickness, we may call it as a shell, so are comparatively higher, like 4 inch, that is 100 mm or maybe 150 mm thick plates, which are being welded together for hemispherical with descent pressure vessels. So in that case, we have to go with the preheating and post-heating. Preheating means, see, whenever we go with the welding, there are two cases. One is the filler metal and the other one is the base metal. So if suppose the filler metal is molten, then it for 80%, 75 to 80%, the filler metal will penetrate and it will melt the base metal maybe 20-25% also. So in that way both sides, the filler metal as well as the base metal, are molten and we get a homogeneous joint. Like for example, this is the base metal, these two plates, and this is the filler metal. So this is melted some 75-80% and this is 25 to 20% base metal is also melted, so that we get a homogeneous joint. Okay, So when this base metal will melt, if suppose it is of higher thickness, then it is very difficult. So in that case, you have to bring this metal near to the melting, near to its. You have to heat it so that the melting process is easier. So that is called as preheating. And if suppose there is a welding done, and immediately after that it is allowed to cool by its own, and if it is cooled faster, okay, in atmosphere, if it is if it is winter days, it's very cold outside, so the welded joint for these thick plates may get solidified, and if it gets solidified fast, there will be 100% chances that there will be a crack which will develop from the center, from the pool, top of the pool. Here we can see like this. Okay, so to avoid that, we require post welding, post heating. That means after welding, we have to go with the heating so that the solidification, and it will be gradual. And because since it is gradual, there will be no more cracks. Okay, sometimes when the welding is done for higher thickness, especially the plates, we also go with the heat treatment process, which is called as normalizing. Sometimes we are going to see the different heat treatment process. So in that we will definitely take this normalizing. Moving forward, this is the inclusion. That is the some foreign particles or foreign material is in being stuck or being accumulated inside the joint. So this is a metallic joint and this is non-metallic. This is nothing but the slag. We have seen the slag layer, which is a protective layer to protect the molten metal from the outside oxygen. So when you are going to go for the second layer of weld, you have to remove the slag, and then you have to use the wire brush to clean the joint. So if this activity is not done properly, then some particles or some traces of the flux particles will remain there, and it will get stuck, because if you are going for the next second layer of welding, then there will be definitely the slag incursion. So the remedy for this is you have to go with the good quality cleaning. Now, this is a lack of fusion. Lack of fusion is improper welding current. If it is very slow, very low current compared to the thickness of the plate and the electrode, and at the same time, uh, if your hand speed is also fast, then it will not allow to fuse properly. So here we can see this is the plate and this is the plate. These two plates are being welded. So this is the weld joint at 90 degree. But here we can see it has not, there is no proper fusion here. So there is a gap. So this is a defect. So to avoid this, we have to use the proper speed, hand speed, and at the same time, a right welding current, directly proportional or depending on the plate thickness and the electrode thickness. Now moving to the fourth defect, that is the porosity. Porosity is nothing but gas bubbles which are stuck or which get stuck inside the molten metal. So this will of course lower the quality of strength for the weld, and the reason for this is the oil or grease on the plates which we have. So when there is a oily or greasy substance and on which we go with the welding, then definitely it will have some gases will be produced, and it will be stuck inside the molten metal like these gas bubbles. So this is called as porosity, and it's a bad quality weld. So to avoid that, you should clean off all the joints from oil or grease. Acetone or CTC is mostly used in that case. So this is the undercut. So undercut we have seen. Here we can see there is a cavity that is produced because of the undercut. High speed of electrode, greater arc length, okay, and holding the electrode at wrong angle. For example, if this is 90 degree, this plate and this plate both are at 90 degree, the electrode should be hold at 45 degree. So if it is not hold at proper angle, then definitely we are going to have this kind of cracks, this kind of defects like undercuts. Okay, the joint quality is not good to withstand the load which is recommended for it. Now moving forward fast, poor penetration. Okay, so it is also low current, improper size of electrode, of course, and improper joint selection and preparation. We have seen different types of joints in our second slide. So third slide. So in that we have seen different joint types. So if suppose improper joint is selected for that, then we may have this problem of the poor penetration. Again, burn through means the plates get burned off and we cannot get good quality welding in that case. So excessive higher currents for thinner size of plates leaves the effect called as burn through. So that's the reason. Underfield, too low welding amperage or too short arc length or too low arc voltage. Okay, so electrode travel and work angles are inappropriate. So because of this, the fusion between the fusion of filler metal with the base metal will not take properly, and so we the weld quality will not be good, weld joint will not be good. Okay, so the too low welding amperage, so we have to use the proper welding current for that. So moving forward, this is the excess reinforcement. This is a weld that is too big or has too much convexity, too much built up, which we can see here like a mountain. Here also, this is the actual photograph, usually caused by low travel speed or incorrect procedure. Okay, so here we can see the weld which is getting deposited unnecessarily. The welded material has come out. Okay, and where it is required, it has not penetrated. So this molten metal should penetrate inside the base metal so that we get a homogeneous joint. But here it has not penetrated. Instead, it has formed a convex surface, and this is kind of a mountain, and because of this the weld may get break up easily at this particular portion, and this material will get easily separated from the joint. So this is called excess reinforcement, and it has no good effect or homogenizing effect on the joint, and because of this the weld may get easily broke easily break up at these particular portions. So this is all, and now these are the spatters. These spatters are because of the higher current if you are using, or if the arc length is high. Arc length means the gap between the electrode tip and the base metal. So if that is recommended in a welding chart. So if we are not following that, then if it is higher, then we get this spark. This spark means it is a molten metal which is not fusing into the joint, but it is coming out. And here we can see this spark. It's like a boil or globules which are formed around the joint. Then we have the overlap. The overlap occurs when the molten metal flows over the surface of the base metal and then cools without fusing with the base material. A typical cause of overlap is the supply of too much weld metal due to low welding speed. So this is the reason for the overlap. Here also it is same like the earlier one we have seen. There is no the joint may get break in this area. So that's the reason for this. So how you feel about this video? Of course, this video was a bit longer. So I request you to share this valuable information with your friends and colleagues. Uh, Keep watching our channel and without forget subscribe to our channel. Thanks for watching this video. Have a fantastic day.